Okay, so let's solve some problems regarding series circuits and Ohm's law. The first problem is, what is the total resistance for a series circuit with three 70 ohm resistors? Well, it's always a good idea to draw the circuit. That way you understand what is happening. You could visually see the problem in question here. So let's draw that, and we're going to use a DC power source again with the negative terminal and positive terminal. We have three loads or resistor values here, and we're just going to draw it, and they're all 70 ohms each. We're just going to put that like that. And the total resistance, as we learned in the previous presentation, is equal to the resistor values, the sum of all the resistors in that circuit. So we just simply add 70 plus 70 plus 70, and we get 210 ohms as the total resistance. All right, so let's take another one. A series circuit that operates on 12 volts and has one 10 ohm resistor and one 20 ohm resistor. What is the amperage through resistor, or through the 10 ohm resistor? Well, just quickly, you know, if the amperage is the same everywhere in the circuit, the resistance through resistor with the 10 ohms is going to be the same everywhere in the circuit. So we know a couple of things here, but let's just draw the circuit again, just for practice. Here's our series circuit, one path, negative terminal, positive terminal, and it's a 12 volt source, one 10 ohm and one 20 ohm resistor. And let's just solve using Ohm's law that we learned earlier in the presentation. Or we could use the circle, which is what I suggest. E equals I times R. And we plug in the variables that we have. We have 12 ohms, or 12 volt source. And our total resistance here, or just use a different circle. We have 12 volts. And our total resistance is 30 ohms. So the circle says to divide 30 into 12, and you would get amperage, 0.4 amps would be the answer there. So we just simply use our circle to understand that. So that's the application of both a series circuit to determine the total resistance, and then using the Ohm's law circle to find the amperage. Now, if the amperage is the same across or through this resistor here, which is 0.4 amps, it's going to be 0.4 amps through this resistor as well, and everywhere in the circuit, because we learned that amperage stays the same in a series circuit. Okay, so let's go to the next problem. A series circuit has three loads, 20, 30, and 50 ohm. If this circuit operates on 120 volts, what is the voltage drop across the 50 ohm load? Okay, so let's draw our circuit again. It has three loads. And this time it's 120 volts as the source voltage. And this is 20, 30, and 50 ohms. Let's determine what the total resistance is, which is 50 plus 50. The total resistance is 100 ohms. Well, we could find the total amperage now that we have the total resistance and voltage. So drawing our circle, volts equals amps times resistance. Now we just plug in our numbers. We have 120 volts, and we have a total of 100 ohms. To determine what our amperage is, we divide 120 by 100. We just move the decimal point over twice, and we have 1.2 amps. Now, the question is, what is the voltage drop across this resistor? Well, if we know that 1.2 amps is coming across it, then we could use Ohm's law and apply it just to this variable, just to this resistor. So again, we could draw our circle, and we see that we have an amperage of 1.2 amps and 50 ohms, and we just multiply 1.2 times 50, and that would be our voltage drop across resistor, across this resistor, which would be 60 volts. And you could do the same for this resistor and this resistor, and when you add up all the voltage drops, you should get the source voltage. Okay, let's go to the last question here. What is the total power consumed in a circuit that operates 24 volts with a total current of 0.10 amps? So this is our power law. And to review, P equals IE, it spells pi, and that says that the power, which is measured in watts, is going to be equal to the amps in that circuit times voltage, or times the volts. And we could again use this by drawing a circle and filling in the blanks. And we apply that circle to our problem now. So we're finding what P is, or the power, and we have amps, which is 0.1 amp, and we have our volts, which is 24 volts. So we just multiply 0.1 times 24, and you get 2.4 watts. 0.1 times 24 is 2.4 watts. So that's how you can apply Ohm's law, the power law, and some rules about series circuits.